came across some research recently on down conductors that's probably
Yeah.
relevant in this case.
So there's a new paper out on lightning protection for wind turbine blade. It's produced by, looks like a number of either students or professors. I can't tell, but the name of it is called Lightning Protection Methods for Wind Turbine Blades: An Alternative Approach. Uh, the paper is based on wind turbines. It looks like it's really based upon a Vestas wind turbine blade, an 80-meter or 85-meter long blade in terms of what the analysis is. So they use a computational analysis using ANSYS, which is a sort of an industry standard computational program. They're using the student version of it. But essentially what they were looking at was the down conductor and how different diameters of down conductor, uh, what the effects they had was they carry lightning energy. So they were simulating lightning current flowing down the down conductor and then calculating what the temperature of the down conductor was and the change in the length of the down conductor. So as a wire gets hot, it gets longer. All metals tend to do that at different rates depending on what kind of metal it is. So they had started off with basically a smaller diameter down conductor, theoretically put current down it, big lightning current down it, and then predicted what the temperature was. So in the smallest case, which I think is 50 millimeter cross section, the temperature rise was about 600 degrees Celsius. That's a lot. In Fahrenheit, it's over roughly 1200 degrees Fahrenheit. That's hot. And the growth of the down conductor was about inch and a half, 2 inches. So it actually got 2 inches, inch and a half to
Mm.
2 inches longer over that 80-meter span. Two implications are: one, as a down conductor grows, it puts stress onto the blade wherever it's held down at, so that down conductor starts to move, tries to make
Hmm.
mechanical other things move. But the second part is that the temperature gets so hot that a lot of that heat is transferred into the structure of the blade, and because the down conductor is on the inside of the blade, where a lot of the load is carried on a wind turbine blade, you can degrade the load bearing structure inside the blade. That's a problem. And so they had done calculations and simulations of 50 millimeter cross section, 100 millimeter cross section, 200 millimeter cross section, and watch how, as you got bigger diameter, the temperature dropped, considerably dropped, and the growth of as the temperature went down, the length of the down conductor varied a lot less. So they were essentially, what they were saying was, you're going to need a certain minimum diameter, and you need to be thinking about the temperature rise of the down conductor so you don't damage the structure and that you don't put extra stress onto the blade structure. So it's an interesting paper that way.